Hello students, in today's session we can see about the piezoelectric transducer. The piezoelectric transducer is an active transducer. It is of self-generating type. It converts your physical quantity directly into the electrical signal that can be measured directly. The piezoelectric transducer is a device that converts pressure, force or mechanical stress into alternating electrical voltage. It is used for direct measurement of physical quantities like force, pressure and stress. The basic principle behind piezoelectric transducer is the piezoelectric effect. The piezoelectric effect results from the linear electromechanical interaction between mechanical and electrical states of a crystalline material. That is, the piezoelectric effect is the ability of certain materials such as quartz crystal, rock salt, barium titanate to generate electrical voltage in response to applied mechanical force. The basic construction of your piezoelectric transducer is shown here, right? So here the piezoelectric crystal is placed inside a closed chamber. The piezoelectric crystal is embedded in is coated with silver plates which forms as a electrode. To the electrodes the force is applied by means of a force summing element. Everything is placed inside a closed chamber and a solid base is used for placing the crystal. The piezoelectric material or crystal. So it is the basic element of your piezoelectric transducer. The materials that produce an electrical current when they are placed under mechanical stress are known as piezoelectric crystals. Here, when a force is applied to these crystals, then the charges will be accumulated on the surface of the material. So due to the accumulation of charges on the surface of the material, there will be a difference of potential energy developed. That difference of potential is measured as the output. The natural material of natural material available with piezoelectric property is quartz crystal, and the man-made crystals are ammonium dihydrate phosphate, barium titanate, lithium sulfate and rock salts. So here the electrodes are formed by silver coating. That is, the thin layer of conducting materials such as silver is coated on the crystal which serve as a electrode. The crystal is placed in between a solid base and a force summing member. The pressure fall on the pressure port. The pressure fall on the pressure port will accumulate in the force summing element and it is applied to your crystal directly. The basic working is of piezoelectric transducer is piezoelectric effect. So here the working is explained here, right? The polarity of charge accumulation on the surface of the crystal depends on direction of the applied force. So here the charge accumulation Q is equal to D into F, where D is the charge sensitivity of the crystal and F is the applied force. The Young's modulus is given by stress by strain. The formula for stress is force, that is force by area, and strain is given by del T by T, that is change of dimension by T. So here force by area by 1 by del T by T, right? So now the Young's modulus E is given as F into T A by A into del T. Here A is the area of crystal and T is the thickness of crystal and del T is the change of thickness and F is the mechanical force applied to the crystal. So from this equation we have to form the equation for force. So from equation 2 we can obtain F as AE del T by T, right? Now substitute equation 3 in your charge equation, that is Q is equal to D into F. So in this F you have to substitute the equation 3. So now Q can be obtained as D into AE del T by T. So now the output voltage at the electrode is due to charge accumulation and there will be two electrodes. In between that there will be a crystal. So that now the parallel plate capacitors. So now V can be obtained as Q by C, that is C is the capacitance between electrode. So already we can formulate the formula for Q, and C is given as epsilon naught epsilon r A by T. Now substitute equation 6 and equation 4, that is we have to substitute the value of Q and C in your equation 5. So from this we can obtain V as, that is here we can cancel T. So now we can obtain as D into E del T epsilon naught epsilon r. Our voltage can be obtained as D by epsilon naught epsilon r E into del T. So that is voltage is directly proportional to your change of dimension. So here D is the charge sensitivity and E is the Young's modulus, epsilon naught epsilon r are the relative permittivity of the epsilon r is the relative permittivity of the medium and epsilon naught is the permittivity of the free space, right? So now your voltage produced will directly proportional to the change of dimension. Otherwise, from equation 2, that is here, from equation 2 we can obtain E into del T as F by A into T, right? E into A del T is equal to F into T, or E del T can be represented as F by A into T, that is force by area is nothing but pressure. So now we can write E into del T as pressure into T. So if we substitute in equation, then we can obtain V as dt epsilon naught epsilon r into pressure, that is the voltage is proportional to the pressure applied to the crystal, right? So here the voltage is proportional to change of dimension, or voltage is proportional to the pressure applied to the crystal or force applied, right? So thus your voltage production depends upon the physical quantity to be measured. The advantage of piezoelectric transducers are high frequency response, self-generating type, hence there is no need of external sources. It is very simple to use and the measuring range will be very large. Barium titanate and quartz crystal can be made in any shape and any form. They have large dielectric constant also. It can be used for measurement of dynamic conditions, that is for variable force, varying pressure, we can use this system, right? So next, the major disadvantage is the output vary with temperature of the crystal. If the temperature of crystal is affected, then the output will be varied. And the humidity also affects the accuracy of the output. Hence, the crystal has to be coated with wax or polymer material. And need of high input impedance cable, that is your charge production is very small and the device operated with small electrical charges and small electric voltage, hence there is a need for high impedance cable and it is not suitable for static condition or static measurements, right? Application already we can see about it, that is it is mainly used for measurement of force, pressure, stress, displacement in terms of voltage directly, and it has excellent frequency response, hence it is mainly suitable for accelerometer. Thank you.